Hello, everyone. Welcome to our live stream on how to ace the computer science and artificial intelligence entrance test. As you may know, computer science and artificial intelligence is a bachelor's program offered by Neapolis University Pafos in Cyprus. It is supported by JetBrains Foundation and offers 15 full scholarships for this program. If you plan to apply, your first step will be taking the entrance test. It consists of two parts, math and programming. Today, one of the program's professor, Pavel Mavrin, will share valuable tips and strategies to help you succeed in the programming part of the test. You can also watch the recording of the math part solutions on our YouTube channel. We shared the link in the comments section. Before we start, I'd like to remind you that we are here to answer your questions. Feel free to drop them in the chat during the presentation and we will address them. Now, let me introduce today's speaker. We are thrilled to have Pavel Mavrin, our expert on algorithms and data structures. Pavel has participated in many programming competitions and was the ICPC World Champion in 2004. Welcome, Pavel. The floor is yours.
Hello, everyone. Okay, so today we'll discuss our entrance test in Neapolis University in Pafos, where I teach algorithms data structures. Our test, like Natalia already told you, consists of two parts. We have math tasks and we have programming tasks. And we published one of the variants of this test from the previous year in Cognitera. So you may have a link, I believe we'll post the link in the chat or add it in the description. So you can go and try it by yourself. So my task for today is to explain you what's going on in the programming part of this test and tell you what you need to do to pass all the tasks and what is the best way to prepare for this test. So in the programming part, we have 6 programming problems, like you see here. The tasks are of various difficulty. First problem is kind of easy. Last problem is pretty hard, especially if you don't have any previous experience in competitive programming, in Olympiad and stuff. So we don't expect you to solve all the problems, but the more you solve, the more chances you have to apply to the program. So you will have 4 hours for both math and programming parts. So you may assume you will have something like 2 hours to solve these 6 problems. That's it. So let's talk about problems. Again, we have several variants of this test, and this year there will be different problems, of course. But the difficulty of problems should be roughly the same, because we tested it this year, and it looks like the difficulty is okay. So the difficulty is pretty fine. So we'll make something similar, not exactly the same, of course, but something similar, problems of the similar difficulty. So you may try. So let's go. So the first problem is like this. So you have n friends. They live on a line and different points of this line. So we know the coordinate of each person. And with the story is like this. So the first person wants to visit all other and return to home. So we have the first person in the one point of this line. So they need to visit all other persons and then move back to home. And the question is, what is the minimal distance we need to travel? Again, problem looks complicated from first time if you're not familiar with math competitions, programming competitions. So it looks like we have some very strange system. We have some people, they need to visit someone. But actually, when you start thinking about this problem, it's not that easy, or not that hard, sorry. So it's the first problem. It shouldn't be that hard. So what's happening here? So we have some people standing in the line. Let me draw a picture, actually. So we have some people standing in the line. And one of them, so let's say here, so this person number 1, needs to visit everybody else and return home. And it's easy to see that the minimal time you need to visit all the friends is just go to the leftmost friend, then to the rightmost friend, and then return back. or vice versa. Yeah. So you need to visit the leftmost friend, and you need to visit the rightmost friend. So you need to visit you need to travel at least this distance. And if you visit leftmost and right, you will visit everybody else in the process. So this is the optimal route, and the length of this route is just difference between the maximal coordinate, minimal coordinate multiplied by 2, because I travel all this distance twice. So that's it. So so after again, so what we require from you for the programming part? You need to read the problem statement, understand what's going on, transfer kind of this story to mathematical reasoning, and then solve the mathematical problem and implement it in programming. That's it. So again, the programming part will be kind of easy. So the hard part in this problem is to understand what we're asking. And let me show you the program actually. So here is the possible solution for the first problem in C++. You can use any language which is allowed in code Gnitera. This be pretty. Let me see. I can solve again. Okay. So here's the list of programming languages. So you can pick any of them. We don't require you to know any specific programming language. So you can look at Kotlin, for example. Yes. Why I didn't do it in Kotlin? I should do it in Kotlin. Okay, but I did it in C++ today. So here is the solution in C++. So what we do, we just read the input data, we read the number of people, we read their coordinates, and here I just need to find difference between maximum and minimum. I do it like this. I just sort them. So the last one will be maximum, first one will be minimum. It's not optimal solution. So you can, so again, if you know, probably sorting works in log n time, and you can find maximum and minimum in linear time. It doesn't matter. It should be good enough. So n is up to 100. So basically, any solution, even it's not very optimal, will pass the test. Yeah. So that's it. So this problem one. Again, the most important skill we need from you is to be able to read problem statement, understand what's asking, and implement simple program that solves the given task. That's it from the first problem. Again, if you, during the test, read the first problem statement and, okay, think the problem is too complicated. No, probably it's not. So probably the first problem is just looked scary. So probably the first problem is much easier than you expect. Okay. So try to read it again, understand what's going on, and try to find some easy solution. Probably the first problem will have, at least first problem will have very easy solution. Okay, do we have any questions? No, no question. So let's go to problem 2. Okay, so this was problem 1. Let's go to problem 2. What we have in problem 2? Again, problem 2 is a little bit more complicated. Here, again, you need to read the problem statement, understand what's going on, but then you actually need to think. So what's happening here? So we have some resources. We have n types of resources, and you have some amount of every resource. So for every resource I, we know the amount of resource you have now. So you have AI units of this resource. And when we have requirements, so to win the game, you need BI units of this resource. So you have basically vector of amounts you have right now, and vector of amounts you need to win the game. And you can need to transform your current situation from this one to this one. Yeah. Okay. So what you can do now? In the next part of the thing, we explain what you can do. So first part explains you what need to be done. So you need to transform from this situation to this situation. Now explain what actions you can do. And the action you can do is just to rate free resource to 1. So you can take 3 units of one resource and trade it to 1 unit of any other resource. Yeah? So we take 3 units of one resource and trade it with 1 unit of another resource. That's it. So the question is to check. So it's yes, no problem. You need to output yes or no. You need to check if it is possible to win the game. So if it is possible to trade resources from the current state, so you have at least this amount of resources in the end. Okay. That's it. So how we solve this problem? Let's think. So we have some amount of resources. Yeah? If we have, let's look at one resource. If you have too little of the resource. If you have not enough resource, then you need to get somehow some more resource of this type. Yeah. For some another resource, you may have too many of this resource. So you have this value AI is greater than BI. So if AI is greater than BI, then you have some excess. You can sell this excess and buy some other resources. So we can easily check how many units of other resources you can buy. You can just take this excess, divide it by 3, and get the amount of other resources you can buy if you sell these extra resources. That's it. And now you just compare how many resources you need and how many resources you can buy. And if you have enough, then it's okay. So let's check again. Pop, 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 pop. Let's check. So here's again my solution in C++. So what's we're doing here? Again, we read the data here. So we calculate two amounts. We calculate how many resources do we need and how many resources we can buy if we sell all the excess resources. So here we iterate all resources. If we have not enough, we increase the amount of resources we need. Yeah. So in the end, this need will be total number of resources we need to buy. Yeah. If we have too many resources, then we sell this excess. Yes. So this is my excess. Divided by 3 will be amount of resource I can buy using this excess. Yes. And then they just check if I have enough resource to buy everything I need. Then yes. Else, the answer is no. That's it. That's problem B. Problem again. This is problem actually harder than the previous one. Yes, you need to actually apply some thinking. So you need to do something using some operations provided, and just check if it's possible or not. It requires I wouldn't say it requires some mathematical thinking, but it's kind of mathematical thinking. So it actually helps if you solved some mathematical problems before. So if you participate in some math contests and stuff like this, so you may see some patterns. So you can see you can see what you actually can do and how you can check this. Even if not, it's actually quite intuitive. So try to apply your intuition. So you see what you can do and just need to check if it's possible or not. I think that's all about the problem B. The popular mistake in this problem was actually to calculate this sum of all excesses and then divide the whole sum by 3. So you calculate total number of excess units you have in total, and then this total sum divided by 3. It will not work because you can only trade 3 units of the same resource. So if you have 2 units of resource A and 1 unit of resource B, you cannot trade it for 1 unit of resource C. Yeah? So you need to do it like this. I believe people made this mistake because they misunderstand the problem statement. So if you get some strange wrong answer, probably you just misunderstand the problem statement. To understand the problem statement, again, try to read multiple times. Also try to read all these sample inputs. And sometimes we also give not here, but in some problems we give some explanation of inputs. So you read all the problem inputs, all the examples, and try to check if these examples actually correspond to what you understand about the problem statement. So if this example doesn't make any sense, it probably means you just misunderstand the problem statement. Just go back, read problem statement once again. Will be submissions checked immediately, like on force? Yes, they checked right in runtime. So you submit your solution, and like in a minute or two, it will be checked, and that's it. So you know the results of your submissions during the test. Yes, and you have I believe we didn't. Maybe we have some limit for number of submissions, but it's pretty big limit. I'm not remember what we did last time. Maybe we limit like 50 submissions or something like this. So we have pretty big limits of numbers of submissions you can make. So you can make submission. If you have wrong answer on some test, the system will tell you, okay, let's make some bug actually. So let's let me show you just what will happen if you have any answer. So let's make this mistake I told you. So if I do this, and then in the end, I will divide like this. Yeah. So I first calculate the total amount of excess, and then in the end, divided by 3. Yeah. So if you submit something like this, oh, you have wrong answer on the test 3. So yeah, again, test 3 is okay. Test 3 is test with low number and test from the input. So from the examples. So first few tests are the tests from the examples here. So if I have failed on test 3 is here actually. So in this test, I have special test. So I have 3 resources. I need to get the 4th one. Yeah. So the answer is no, because you cannot sell these 3 resources for this one. Yeah. You only can sell 3 resources at the same time. Okay, hope it's clear now. Any more questions about second problem? Don't see. Okay. Okay, let's move to problem 3. Okay, problem 3 has actually very short problem statement. That's also happens. So we kind of want to balance between problems with long, complicated problem statements, and some problems will have very short problem statements, like here. So it's very short and it's very formal. So what we have here, we have array, and we want to make it sorted. We make it sorted by performing some operation. In one operation, we can decrease element by 1. Basically, we decrease some elements. In the end, we have sorted array. It's not sorting algorithm, but we just move from initial state to some sorted state. Right. Question is to find the minimal number of operations you need to perform to make the array sorted. So again, very short, very formal problem statement. So it should be very clear what you need to do, but it's not clear how to do it. So if you just do operations one by one, the total number of operations may be quite high. We don't have this. Okay, no, like in these problems, like you may have, like in the third example, you will have situation when I have very small array of size 3, but I make like 200 operations, even for this kind of small array. So, and if you have larger array, if you like a 10 power 5, you may have size of the array maybe up to 100,000 elements, and elements are up to 1 billion. So if you have situation like this, so you have some big numbers and then a small number, then you need to decrease all these big numbers to be the same as this last small number. And so total number of operations will be very high. So you cannot just do operations one by one. You need some fast algorithm to do it actually. Okay, we'll do it. Okay, I'll talk about this. Yes, I'll finish this problem and we'll talk. So how to solve this problem? Tricky problem. Multiple solutions possible. The easiest solution probably in this problem is just to think what you cannot do. So you look at the first element. Can you do anything else? So you need to kind of decrease the first element. Yeah. So you need to decrease elements so it is minimal element of everything else. Yeah. So you decrease element to the same amount to this minimum of all other elements. And so on. Every element should be decreased to the minimum of all elements after it. So because we cannot increase the element, yeah. So all elements to the right. So like look at this 5. Yeah. Let's look at all elements to the right from this 5. They will not increase because we only can decrease elements. Yeah. So all these elements will be at most 2. Yeah. Because of these 2. These 2 will never be greater than 2. So we need to make this 5 be less than this element. So this 5 should be decreased to at least to value at least 2. So we need to decrease it at least 3 times. And so on. So you look at all elements and think, okay, what is the minimal number of operations I need to do at least to do something with this element? Another way of doing it is to look differently. So you can look at the last element. So the last element, it doesn't make sense to decrease the last element, right? Why should you decrease the last element? So it is the maximal. So in the end, it will be the maximal element of your array because array will be sorted. So last element will be the maximal element of the array. So why should I decrease the maximal element? I shouldn't decrease the maximal element. So you keep the maximal element, the last element as it is, and go to the previous element. And now for the previous elements, it is clear if you need to decrease it or not. Yeah. So if the previous element is greater than the last element, then you need to decrease it. And you know to which value you need to decrease. You need to decrease to the same level as the next element. Yeah. And so on. So you go from right to left. If you go from right to left, you can easily fix the final value for each element. Yeah. So you take the final, the last element, the value stays the same. Previous element, the value is the same, or the value of the last element, and so on. So every time you pick the element, you look at this element and the next element. If it is above the next element, you decrease it to the same level. And that's it. So this is probably the easiest solution for this problem. Let's look at my code again. So that's it. So code is kind of short. So what's going on here? I just go from right to left, like I told you. So I skip the last element. I go from element n-2 to 0 from right to left. And check if my element is greater than the next element. Then I need to, again, decrease it to the same level as the next element. So I add this number of operations to my result and make my element the same as the next element. That's it. So that's the whole algorithm. So you go from right to left and calculate number of operations you need to make. Okay, that's the first problem. Again, it's kind of tricky problem, not the easiest problem, definitely. But the code is kind of short. So we want to kind of balance between problems when you need to program and problems when you need to think. So in this problem, you need to think actually. So you need to think what we need to do and how to do it fast. Okay, so the question, how do you recommend to organize your preparations to spend more time on algorithms or ideas? That's a tough question. You kind of need both. You need to, I wouldn't say you need to spend time on algorithms because we don't require much algorithmic knowledge here. So algorithmic knowledge will help, definitely. But I would say much more will help just the skill of solving problems. So I would recommend just to solve more problems of this level. It will help you just to see the patterns in the problem statement and see the how would you solve this situation and this situation. Basically, when you solve a lot of problems of the same type, at some point you see the patterns. Yes. So you see, okay, I can do this using this technique, then I do this using this technique, and then kind of combine these techniques to make the full solution. So we don't need any algorithms. Maybe we will. So I wouldn't say I would not use. We will not require any algorithms. Probably in some problems, you will need something like, I don't know, binary search or simple dynamic programming or something like this. But it will be or just few problems like this. Most of the problems will not require any algorithms. Just basic skill of problem solving. Okay, it's not very basic actually. I say basic, but it's actually not. So this problem is not the easiest problem. Yes, but you need to you don't need to solve all the problems. Okay, so you solve as many as you can. Okay, hope I answer your question. Let's go next. Okay, fourth problem is specifically pure implementation. So we don't require to use any special thing here. So you read problem statement. In problem statement, they kind of tell you what you need to do. So what's happening in this problem? We have this two-dimensional board, and we have some arrows. In every cell, we have arrow to some neighboring cell. And you just need to check if you start in one cell, you will finish in another cell. Yeah. So you start here in the bottom left corner, and just follow these arrows until you finish in the top right cell. If you finish in the top right cell. Yeah. And you need to count number of steps you do, or say it is impossible. Okay, maybe tricky part is to check it's impossible. Everything else is pure implementation. So again, so what you do, you just simply simulate this process. You need to read this input, and just simulate what's going on. So you start in this cell and just move along these arrows. Just remember what is your current coordinate. So you remember your current coordinate, you move along these arrows and check if you finish here. What can go wrong? Okay, small thing can go wrong. I believe the trickiest part of this solution is actually to check if you will reach this top right corner at all. So sometimes you don't reach this top right corner. Do we have examples? We don't have examples. Okay, it's not good. We should have examples for this, but okay. We're evil in this problem. Okay, so how would you not reach this top right corner here? No, what can go wrong? Basically, two things can go wrong. You can fall out of the board. Yes, so if you have error which moves you out of the board, then you will not reach the top right corner. Or if you fall into cycle. So if you have cycle, you may go cycle and never reach this top right corner. So there are two things you need to check. You need to check if you fall out of the board or if you fall into cycle. That's it. Okay, there are many ways to do it. Okay, so it's easy to check if you fall off the board. Just remember your current coordinate. If your coordinate is out of the board, then you just output impossible. Impossible is like -1. Okay, just output -1 if you fall out of the board. How to check if you're in a cycle? That's more tricky part. So there are multiple ways to do it. You can, for example, mark all the cells you visit, and if you visit the same cell twice, then you are in a cycle. Or you can maintain the set of all visited cells. And again, if you visit the same cell twice, the easiest solution is actually to check if so just to make these moves and stop if you make too many moves. So if there is a path from here to here, the number of moves will be not greater than size of the board. Yeah? So if number of moves you made is already greater than the size of the board, then you're definitely in some cycle. Yes, because you started here, you visited some cells, and like you visit number, okay, n multiplied by m. So if you visit already some n multiplied by m cells, and you never visited this top right cell, it means you've visited at least one cell twice. Yeah, by pigeonhole principle. So that's it. So let's check my solution. Okay, now we have pretty long program, longer than before, because this problem is mostly about implementation. So what we're doing? So how I do it? I maintain my current coordinates as in this way. So I have row and column of my current cell. I start in row n-1 and in cell 0. So in top and in bottom left corner. Yeah. Here, I make the steps. So let's keep this for now. So here is one step. So I look at my current cell and just make one of these moves. So if I need to move to the right, I increase the cell coordinate. So here I move to the left, I decrease SE. So if I move down, I increase R. So if I move up, I decrease R. So here I make one move, and here rest just count number of moves. Now the tricky part is actually this if. I believe it is the most trickiest part of this program, but it's actually here is it. So what we're doing here? So we check if we fall out of the board, then we output -1. And if number of moves is already greater than the size of the board, it means we fall in the cycle. It means we need to again output -1. So again, so this check may be intellectual. Everything else is pure implementation. So you need some programming skills and just to implement what's going on. And I believe that's it. Okay, we had some question. What resources? Okay, let's finish. Let's do it in the end. So in the end, I will show you probably some resources you can use for preparation. Let's discuss the last two problems first, and then talk about how do you prepare. Problem 5. It's actually a very mathematical heavy problem. So again, we want to kind of find balance between programming problems and math problems. So in some problems you need to think, in some problems you need to program. Here you mostly need to think and then do some programming as well, but not that much. Okay. So what's happening here? You need to count number of ways to color dominoes in 3 colors. So we have this rectangle 2 by n divided into dominoes. So you already have, it's called domino tiling, doesn't matter. So you have this rectangle 2 by n split it into rectangles 2 by 1, like here. So here's one example. So here's from the first example. So here, this. So here's one example of domino tiling of this. So you're already given this tiling, and you need to just color it. So you color it in 3 colors: red, green, and blue, and you color it so you don't have touching rectangles of the same color, like here. So in this example, I have 2 red rectangles touching each other. You're not allowed to do this. Here they can touch by the corner, like here. 2 green rectangles, it's fine, but touching by side is not allowed. And again, what you need to do is count number of ways to color all these triangles. It's actually a combinatorical problem. So if you study some combinatoric again in your math class, that may help. And even if don't, it shouldn't be that big problem. So some knowledge about some combinatorics will help, but even if you don't have any previous knowledge of combinatorics, it's still a solvable problem if you at least have some mathematical skills. Go. So how we solve this problem? No. First, how you approach problems like this? First, you play with the model they given to you. So we're giving you some object. This object looks like this. I have rectangle 2 by n, split it into rectangles 2 by 1. You look, okay, how this object looks like. So what can happen in this object? And you probably see that something like this. So you have this rectangle. So let's see, how can we split it into rectangles 2 by 1? So let's go from left. So what will happen in this leftmost part? I may have either vertical domino like this, or I may have 2 horizontal dominoes like this. And every time you have you pick one of these objects, so you have basically 2 blocks. You have block like this, 1 vertical domino, or you have 2 horizontal dominoes like this. And basically, this tiling is composed of these 2 types of blocks. Yeah. So if you go from left to right, so again you put one of these blocks to the left, then again you have this kind of flat edge in the left. So again you pick one of these objects, put here, then again put one of these objects here, then again put something here, put something here. So every time you put one of these objects, and again you have the flat side here. So you need to again put one of these objects. And that's it. So basically, now you understand how this model looks like. So now we understand what's happening inside this model. Yeah, it's a very important step to solving the problem. Is actually just play with the model to have more understanding of what's happening in it. Yeah. Now let's go to the problem. Now when we understand how the model looks like, let's solve the problem. So we have these blocks. Let's color these blocks from left to right, and just count how many ways do we have to count to color these blocks. And let's go. So for example, imagine we already colored to this position. So we already colored everything to the left here. And now we need, let's erase this. And now we have vertical block, let's say. And we need to color this vertical block. How many ways there are to color this vertical block? Well, it depends on what's happening before. What may happen before? For example, if here you have 2 horizontal blocks, let's have block of size 1 of type 1, block of type 2. Okay, so if I have block of type 1, to make it short, yeah. So if the previous block was of type 2, yeah, then how many ways is to color this block? No, it's only one way, yeah, because you have some 2 colors here. For example, you have, I don't know, you have red color here, and you have, for example, green color here. So you already used 2 colors out of 3. Yes, and this block touches both of them. Yeah. So to color this block, you have to use blue color because there's only one color not used. Yeah. So when you have block of type 1 after block of type 2, let's make so and then you have block of type. There is only one way to color the block. Okay. Now, if you have block of type 1 after block of type 1, how many ways to color this block? Oh, you have 2 ways to color this block because you have one color used here, for example, red. So here you can use green or blue. You have 2 options. Yeah. So if you have a situation like this, then you have 2 options. And again, it doesn't depend on what's going on before. So it doesn't matter what's happening here to the left from this. So anything can happen here. You always will have 2 options to color this block. And now you kind of you explore all other options. So what may have? You have block of type 2. What's happening before? You may have block of type 1, and again, you may have block of type 2 after block of type 2. So in this case, so in case, let's say this black is red. So now these 2 blocks should be colored in blue and green. Yeah, and you have 2 options. You can color them blue and green, or green and blue. Yeah, so here you have 2 options, and here is the most tricky case. So you have some 2 colors here. And you just play with this model and see how you can color these 2 blocks, and you can easily see that there are actually 3 options to color these blocks. I will not show you all 3 of them, but again, if you just play a little, you can see all the 3 ways to color it, and that's it. And this is all options we have. Now we just look at our the tiling given to you in the input. Okay, let's go. Let me draw the so this is from this statement, and just count how many ways to color. So we go from left to right. So this first block, so nothing is to the left, so I have 3 options to color this block. Now for this block, again, it is block of type 2 after block of type 1, so I have 2 options. Now here I have 3 options, here I have only 1 option, and here I have 2 options. So the result will be just product of all these numbers because they're independent. Yeah, I go from left to right. Every time I know how many options I have. So total number of variants will be just product of all these numbers. So it'll be 2 multiplied by 3 multiplied by 3 multiplied by 2 multiplied by 2. It's 9 by 4. It's 36, right? Let's check. So again, it's important to check if your thinking actually correspond to it. So this is the same input, looks the same. So input is 36. Okay. So again, so I try to solve this problem by hand, get the same answer. It basically usually means that I understand the problem correctly. That's it. So this is the whole solution. So we will split all this rectangle to blocks, go from left to right, and count how many options do we have in every moment. Just that calculate. Just multiply all these numbers and get the result. Let's look at my solution here. It should be pretty short. Yeah, that's it. Okay, so what I'm doing here, let me see. So here, I check which block do I have. I do it like this. I compare AI and BI. It basically compare 2 vertically aligned these 2 elements. So A is the first string, B is the second string. So I compare AI and BI. If they are the same, it means I have vertical block. So if I have vertical block, I do this. If I have horizontal block, I do this. And here I basically multiply some magical numbers. Okay, I get these magical numbers by just drawing some pictures on a paper, like I just did. Yeah. So you explore all the options you have and count these numbers, and then in the end you just take all these numbers and multiply them and get the result. Okay, hope it was clear enough. Again, it's one of the last problem. It's fifth problem out of 6. So it's supposed to be kind of more difficult than the previous one. In this problem, you need to have okay. So you have you need to have at least some experience in math competitions. I would say maybe not programming competitions. Okay. Programming part, like you see, it's kind of not very complicated, but math part is complicated. So you need to have at least some experience of solving some problems when you need to count something. So if it is your first time, if you have problem like this, you maybe spend too much time. Again, I believe even if you don't have experience, it problem is solvable without any experience. But problem is you have only 2 hours to solve all the problem. So basically for 6 problems, you roughly have 20 minutes per problem, right? So 20 minutes per problem like this. Okay, maybe you solve first problems faster, then you have like half an hour to solve the problem. It's still not that much time. So you need to have at least some experience of solving this problem before to make it faster. Do you have any more questions? About resources, we'll talk about resources in the end. Okay, let's finish discussion of all the problems first. Final problem 7. Problem 7 is actually kind of difficult problem, even for people who have some experience in programming competitions and stuff. It may be difficult, so we kind of expect some people to have difficulties. So it will be boring if everybody solve all the problems. So last problem actually is a real problem. So what's happening in the last problem? We have a gray code. If you don't know what gray code, so here is a very short explanation of the gray code. Basically, gray code is a cyclic code where the 2 consecutive code phrases are different but in only 1 bit. So we have okay. Let's read carefully what's going on here. So gray code is an ordering of all possible binary vectors. So if you have n bits, you can you have n bits like here. Okay, let's have this example. So imagine you have 2 bits. So you have 4 options how you can make it to these 2 bits. Okay? And we want to arrange all these 2 power n vectors in such a way that any 2 adjustment vectors are different in only single position. Yeah, it's called gray code. Also, gray code is a cyclic code. So first and last vectors also should differ by only in 1 position. Nice. So this is what the gray code is. It's actually interesting to explore. So if you never saw gray code before, you can just Google and check what interesting properties gray codes have. But you don't need it in this problem. What you need in this problem? So you have some gray codes, but you replaced some bits with question marks. And the task is what we need to do? We need to replace back. So we need to replace these question marks to bits, to zeros or ones, to get the correct gray code. It's actually a very interesting problem. Like here, let's look at this example. So we have, every second bit here is replaced with question mark, and we can replace them like this, and here obtain the correct gray code. So we have ordering of all bit vectors of size 2, and every 2 consecutive vectors are different in only a single position. So here different in the second bit, here different in the first bit, and so on. That's the problem. So how to solve a problem like this? Again, let's try to think. So I have question marks. I need to replace them with zeros and ones. There are too many options. So if you just try to brute force, it's kind of too much. But let's try to fill at least something. So let's try to have at least something. So imagine I have some first vector. Let's say you have some 1, this question mark 0, 1, 1, something like this. So you have this question mark. You can replace with 0 or 1. You don't know which. So let's try to guess. So for the first question mark, let's guess. For example, let's put it in red. So we put 0 here. Now let's look at the second vector. So we'll have second vector. Let's say you have something like 0, 0, 0, question mark 1, 1, something like this. So we have another question mark. What bit you should put here, 0 or 1? Now it's actually you have only one option, because you know that the difference between these two vectors should be only in one position. Yeah, but you already have this bit, so this bit is already different. Yeah, so if you put one in this position, you have two different bits. You're not allowed to have two different bits. So if you already have one bit which is different from yours, then you know here you should put the same bit as here. So you have only one difference here. Let's make it actually. Let's also make it red. Now, if another situation. So if you have, let's say, something like 0, 0, let's say 1 and here question mark. So if you have all here, you have all bits are the same except this question mark. But I need to have exactly one bit different. Yeah. So all bits are the same. So this difference should be here. Yeah, because it's nowhere else. So if all other bits are the same, then here instead of question mark, you need to put the opposite bit. You need to put 0 in this position, and so on. So for every next question mark, it's only a unique way to put a bit in this position, because you know the difference between this vector and the previous one. Yeah. And so on. So now again, we can take all the question marks one by one and replace them uniquely with bits. That's it. So in the end, you replaced all the question marks with bits. Now you finally need to check if you obtain the correct gray code. To do this, you basically need to check what's written here. So you need to check that your vectors contain all 2 power n different vectors. So you contain all different vectors, and to adjust just different only single position. It's actually will be done by itself, except the difference between first and the last. So you need to check the first and the last bit vector if they differ in only single position. That's it. So that's how you solve the last problem. Again, it's tricky solution. You need to you have some strange model. It's not very easy model to deal with. So you have some gray codes. If you never saw some, you may never saw some bit codes before. So if it's the first time you see bit codes, you may have some problems. But again, it's kind of explained here. So again, after some time, you understand what's going on, and then you solve the problem. Again, solving problem is tricky by itself. So you don't know how to solve the problem. So you need to try something and then figure out what will happen. So again, like here, you put one bit, and then you figure out all the other bits, because it will be uniquely determined. And after this, even if you solved all this, you still need to program this, and the program is not easy as well. So let me show you. So it's the longest program of this contest. It's long. Okay, it's not very long, but again, it's like, okay, I have almost 60 lines of code. Okay, you may do it shorter. It's not very optimized for the length of the code, but it's not easy problem in any sense. So let's see. So what I'm doing here. So I read all the data here. Here I choose which bit I will put in the first vector. So I may put either 0 or 1. Now I will copy all my strings to another array just to save them, because I have two options. I will just replace all the question marks with bits, so I don't forget the initial state. I'll just remember in array A. So array B is my copy. I replace the first question mark with F here, and now I look for all other vectors starting from 1, yeah, and check what is difference with the previous vector. If all bits are the same, I make the bit different from the previous one. Here I make check score 1, just replace 0 with 1, 1 with 0. Yeah. So you take the previous take the previous vector, take the same bit, and just invert it. And if you have if you already have some inverted bit, then I just take the same bit. If I have more than one inverted bits, I just say it is already impossible. Now, if everything goes right, then in the end, I have some code. It may be not correct gray code. So let's check. First, I check that it contains all 2 power nx. Here I just check that if I put all these strings into set, size of this set will be equal to number of vectors. M is just 2 power of n here. So I just check that if I put them in the set, I have so basically I check that they all are different. It's one of the way to do it. Maybe one of the shortest way to do it is just to put them in a set and check that size of the set is as you want it to be. And here I check that a difference between first and the last vector is also 1. That's it. Now, in the end, I just say if it's okay. Okay means I guess the first bit. So again, remember, I need to guess the first bit. So if I guess the first bit correctly, then in the end, I will have correct gray code. So if I get the correct gray code, I just output the gray code. If I try to put 0, didn't help. Try to put 1, didn't help. So this first bit can be either 0 or 1. So if I tried both and they didn't work, it means the answer is no. That's it. So that's the 6th problem of the programming test. Again, problem is okay, this is a really hard problem. Not that many people solved this problem during the interview last year, but some people actually solved the problem, so it's very good. Do we have any more questions about problems? I don't see. Natalia, did we have any questions about problems?
No, we have all the questions answered. Thank you very much for your presentation, Pavel.
We forgot to ask about resources. People ask me what resources you may use to prepare for the competitions. Basically, any site that gives you some problems like this and allows you. I would recommend some site with automatic testing system. There are many of them: Codeforces, LeetCode, some stuff like this. So just pick one which you like the most and choose the problem of appropriate difficulty. Just try to choose the problems which are hard for you to solve. That's what I recommend. So just adjust the difficulty so you can solve this problem, but not immediately. So you need to spend some time solving this problem. So then when after it became easier for you to solve problems like this, you just increase the difficulty and solve harder problems and so on. That's how you progress, basically. That's it from my side.
Thank you. Thank you for being here with us today. You can also ask your questions in our Telegram chat and by email. And see you soon. Bye.
Bye.